Yes, welcome to Julia's journey in smart factory design. I'm your host, Julia Żywiecka, and today we are zeroing in one of the fastest evolving and most critical sectors in modern manufacturing, PCB factories. Printed circuit boards are at the heart of every modern device, from smartphones to satellites, and building them more smarter means better performance, better energy use, and better results across industries. So, how do we upgrade a PCB factory? How do we turn traditional processes into smart, agile, and data driven systems? With me is our CEO and founder, Alexander Stepinski, to explain how we do it and why it matters more than ever. So let's start with the basics. What makes a PCB factory smart? How does the system work?
So traditional factories, very manual. People used to load and unload machines, basic chemical controllers, basic PLCs, things like that. It was kind of the mainstay. And past 10, 20 years, you see a lot more automation. So the loading, unloading is automated. But the chemical controllers didn't really improve so much. And the integration of individual work cells never really advanced very much. So this is where we focus, is on integrating work cells into larger systems, super work cells basically. And we focus a lot on the chemistry and the controls. So chemistry wise, we tend to recycle a lot of the chemicals now. We have different means of attenuating the individual components of the chemistry to reduce the variation and then improve the capability of the process. And when you improve the signal and reduce the noise for each of these variables, then you can actually pull these signals, pull these levers, and get desirable results. So now that you have levers that you can pull, what's missing is measuring the product so you know the relationship between the lever and the product. So we provide metrology solutions to measure, and then we also work with machine learning to go ahead and say, okay, what we measured is X, and the lever needs to be pulled this much to get a better result, to get the Y result we were targeting. And what happens with the machine learning is, as you do more and more of these kind of reflections, you build models without the need for human involvement in the model development, and maybe some supervision initially, but as time goes on, rational sampling plan takes over, and there's fewer and fewer exceptions that need to be monitored. And so we do a synthesis of all this, improve chemical controls, circular economies. We also identify what the best controls are in general for a given product type, where we need to have the most control. So we have easier to tune controls, machine learning, metrology, circular economy systems. Even we put the lab on the machines. This is what makes a factory smart. This is what makes a factory smart.
Okay, so it's all about full control.
Yeah.
Real-time data and precision and traceability. And I know these aren't just upgrades, they are transforming the entire operation. So why is this technology especially important right now?
Well, right now, there's many reasons for it. One is we have a lot of geopolitical challenges right now. So there's a great desire to localize printed circuit board manufacturing, especially bringing it back into the Western world, particularly the U.S. But also we have a big drive for more complex products with AI. And taking all of these methods together, what it does is, on the U.S. side, it reduces the labor requirements, reduces the environmental challenges, and it makes reindustrialization in the U.S. possible. On the advanced products, particularly the AI servers, things like that, these products are, interestingly, they're quite advanced. A lot. Drilling time for AI server cards, it's similar to semiconductor test boards. It's sometimes more than a day. to drill some of these things. A lot of back drilling, build-up layers, very tight signal integrity, and higher layer counts. And this is all what I would call complexity. And how do you address complexity? You don't throw more labor at it. You have to improve your control level, because otherwise higher complexity will lead to lower yields. So smart factory concepts, when applied, take complex products and make them yield the same as simpler products did before. And it also can mitigate the challenges in reindustrializing Western countries. So that's the great benefit.
That makes sense, especially with the global demand for microelectronics skyrocketing. But how do clients benefit once the system is installed? Well, what are the main benefits of smart PCB factory systems for our clients?
There's two big benefits. I would say the first big benefit is making money. Okay, so when you apply all these techniques with experience and knowledge, then you end up getting a much better investment return than you would otherwise. First thing. The second thing is sustainability. So our factory designs do not have any air emissions, no liquid emissions. They use less water than the bathrooms. And also the individual chemical controls. We have circular systems on many of the different chemistries in the factory. So you need to buy less chemicals, you need to transport less chemicals, and there's less risk of harm coming from all these chemicals. So these are the big advantages. And imagine you adopt our practice and then the person down the street does not. And when the environmental restrictions change in 10 years, that person's shop will be shut down and yours will not. So there's a lot of benefits.
Yeah, so we're talking better yields, better tracking, and less waste.
Yeah.
But I imagine the setup process is different for every client. So can you walk us through how we tailor solutions for each factory? I mean, how we customize the system for different types of PCB factories, production lines. Yeah.
Yeah. So it's the scientific method. We go and we collect the data. So our data collection is very significant, I would say. Probably an order of magnitude more than the market currently does, at least. So what we do is we work with the client, we identify the products they want to build, we analyze the actual design data of the products, we go and we check references on how this product is built in the market. We then go and make a working hypotheses of different scenarios of here's how we could build this product. So some clients might want to have the best ROI, and some might not want to have the best ROI, but are interested in some hybrid of cash flow and ROI. So a lot of the design is tailored to the financial situation of the investor and also the scale of it. So they may want to start small and get big. Some people want to just go boldly in and invest everything all at once. And so we go and make different scenarios and models based on the customer's financial interests. And that's how we do things a little bit differently. And then another way we do things differently is we're truly global, and we're traveling a lot. So we're constantly on the road, looking at the new technologies, looking in factories at how these technologies are applied, getting the lessons learned, the pluses and minuses. And then when we do our projects, we apply all these lessons learned, and we have so many lessons learned compared to typical implementations that are done by traditional players. We get huge benefits, huge benefits to all this. And the benefits can be capability. The benefits can be, I can build a product I could never have built before. I can get into a new technology sector I couldn't get into before. I get new clients I couldn't get before. The other thing is I can operate at a lower cost than I ever could before. I can operate safely where I couldn't operate safely. I had environmental risks before. I don't have them now. So these are all the ways that we.
So it's smart engineering based on data and goals.
Yeah, yeah.
Are there any trends we are seeing in PCB manufacturing, like that are pushing demand for like smarter solutions? I mean, like what trends are shaping the future of PCB manufacturing?
It goes right back to the first question. I think geopolitical challenges where everybody wants to build locally is one, and then I think the great push to AI is another. Also, unfortunately, the geopolitical challenges also result in the need for a lot more defense and aerospace products, which it's generally unfortunate, but necessary. That every country has their own independent source of this production. So these are the big trends: the defense and aerospace products, and the AI products, and just reindustrialization of generic products. It's all totally different technologies, totally different approaches. The AI server stuff is mass production, very similar part numbers. The defense and aerospace, you have mass production of some very simple parts for like drones and missiles and things like that. But aerospace, very few part numbers. Very few pieces, high number of part numbers, high mix. And then you just have generic production, which is mass production of a few part numbers. So each one of these fields has different challenges, but these are the three thrusts that we see in the global market right now.
Yeah. I think a lot of listeners might not realize how fundamental these factories are to the tech and they use every day. And now they're not just producing, but they are evolving. So thank you, Alex, for giving us a closer look at how smart factory design is reshaping PCB production from the inside out. In our next episode, we are staying technical, but shifting focus to one of the biggest challenges factories face: wastewater recycling systems. How do we make heavy industry cleaner? How do we build recycling systems directly into production? So that's up next. See you there.